I derived extends I first, I second like this. Multiple and multi-level inheritance, both are there. So a contract allows to extend another contract. Here, one important question is there. The question is actually, you are saying interface is to configure rules. If interface is to configure rules, and every rule that you mentioned must be implemented by the component, then why it have optional rules? Why you have optional rules? You are saying rules, and why you are saying again optional in rules? You are saying that this is the rule, and you are also saying that you can ignore it. How it happen? How you can say that? So why we can ignore the rules? Why we should ignore the rules? What is the necessity? That means the question is, why to configure? Why why to configure optional rules in a contract? Why to configure optional rules in a contract? Why to configure optional rules in a contract? Because actually rule means you have to follow. You are writing a rule and you are saying you can skip it. Then what is use? And why you do that? What is the necessity for that? Why you are mentioning rules as optional? Why you need optional rules, nullable rules in an interface? The point is actually optional rules are required for one reason. Generally, whenever we design a project or whenever we design a module is meant for a specific purpose. Actually, a project comprises of several modules. For example, you have a shopping app. In that shopping app, there will be several modules like customer module, like admin module, like vendor module. So wholesale, retail modules will be there. That means every module have a different functionality. So vendors can log in and they can upload the products and their details. So admin can manage those products. User can only watch them, browse them, and add them into cart and buy them. Like that, a project comprises of several modules. And generally, for every project and every module, we have two basic things. One is every project and module have an objective, and it will have a uh, goal. A project or a module is defined with objective and goal. What is difference between an objective and goal? Every module have some objective and every module have some goal. A project have objective and a goal. What is objective and what is goal? What is difference between these two? Actually, objective means it must be achievable. Objective is always achievable and it is time bound. That means you must able to achieve it and within specific time. These are called as what? Objectives. Goal means it may or may not be achievable. If you achieve it, it's okay. If you don't achieve it, so it's fine. There is no concern. You achieved it, it very good. Not achieved it, it's fine. That's not a big deal. That means it's not a big worry. For example, suppose you are designing a project like bus ticket booking. In this bus ticket booking, availability of bus and reservation and live tracking. These are the features. Now, which can be optional? Which can be optional? Live tracking can be optional. Why? If availability is not working, then what is use of that app? That app's main purpose is show the availability of bus, book the ticket. If they are not working, there is no use. That they should work. They are all objectives. Live tracking is a goal. That means it may work, may not work. If it is working, very, very good. If not working, it's fine. We have alternative ways for that. That means this is an optional feature. Optional feature means you have to implement it. But if you are unable to achieve it in every situation, it doesn't matter because we don't completely depend on it. So it is optional. That is what we call as goals. That means you say that my goal is this. What does it means? Will you 100% achieve it? May or may not. Objective is this means you must achieve it. Whenever you design a component or a project module, for that we have goals and we have objectives. How to design goals? Because goal can be achievable or may not be achievable. That means it is not mandatory, it is optional. So what is the answer is why to configure optional rules to implement goal of any module or component. To implement goal of any module or component. So here the point is what is difference between objective and goal. Objective is always achievable. Achievable spelling, what is it? Is achievable. Achievable is always achievable and a time bound. Goals are optional. Goals are optional and don't have a time bound. And simply say that and are not time bound. This is the point. So if anybody asks like You are saying rule and you are saying ignore the rule. How it is possible? Why we should ignore a rule? Because it is a goal. It is not an objective. So that is the reason you can ignore that. So that is the concept of interface here. So I will copy this example. This is an example of interface with multiple inheritance. Single inheritance, multi-level, multiple, you can implement all of that here. So this is one new concept. So in JavaScript, you don't have any interfaces and the interfaces are managed here. Now, another point is, remember, I already told you, don't try the concept of watching the JavaScript file generated by TypeScript and try to understand the logic it created. That means many people, what they do is JavaScript don't have interface and TypeScript is having interface. Then how it will convert into JavaScript? In JavaScript, there is no interface. How it will use interface? How JavaScript will use interface? That means if you look at the design, you look at the design of JS file generated. This JS file contains an ordinary product only, just ordinary object. There is nothing about interfaces extending. That means don't think that JavaScript file is going to show you all the background translation, what it has done, how it managed interface, how it handled interface. It will not show all of that. Only what is needed for output, it will show you. That means you are simply asking like, we given a medicine for fever. Doctor given a medicine, a tablet for fever. You taken the tablet and fever gone. You ask doctor, how it is gone? Explain me. Means you are asking how it is gone, explain me. Even doctor can't explain you. That means he can explain the process. He will say that it will dissolve into your blood, it will go into the blood. You can't ask me, show me. Then he have to postmortem you. Huh? It's not possible because this is internally done by the compiling system and finally what output is required, that is generated. That is the reason many people are confused. Like, so you are writing interfaces, you are writing all this, but in JavaScript it is showing ordinary object, how it works. How it works, you don't worry. The compiler will take care. Internally, it will manage everything. And finally, what is required to show as output, that is generated. Everything is not generated. That means how it converted an interface into its understandable format, it will not show that in the code. So code contains only what is needed for the output. It will not convert everything. It will not show you everything. It's not possible. That is the reason never try to understand the JavaScript file generated by TypeScript. It is waste of time. Why? Because several contents are hidden and managed and they are not shown in the JavaScript file. Finally, output is given there. You have to just use it. So that is the reason you will never see interfaces. You see your written interfaces. How it used the interface, how it inherited it, how it implemented it. That's all compiler will take care internal. And finally, the output is generated for that. So that's important. Next important in that OOP concept of TypeScript. So one new thing you learned is about interface. Another important new thing is the class in TypeScript. Already I given you all the definitions about classes, class members and all. You know them. But what is new in TypeScript class? That I will explain, because already class related concepts we discussed in JavaScript. While discussing class components also I explained. Now, technically, what is new in this TypeScript class is actually class configuration and members are same as in JavaScript. Class configuration and class members are same as in JavaScript. That means what is class configuration means you can declare a class or you can use class as an expression. Class have declaration and class have expression. Already we know that. And members are same. What are the class members? A class member can be a property, accessor, method, constructor. Only four are allowed in a class. Those are common things. But what is new here is TypeScript class can have static and non-static members. TypeScript class can have static and non-static members. So a TypeScript class can have static and non-static members. This is something new directly to define, because the word static is not allowed in a JavaScript file. In JavaScript, it is not allowed. What is static and what is non-static, and when and where we have to use it? Generally, to understand this concept, for example, if you ask this question to Java, C++, all these people, C Sharp, what is static, non-static? So you will see some definition which is not satisfying. Like almost all people who learn OOPS, if you ask what is static, they will give you an answer like static members are accessible by class name. You will see the definition regularly, that static members are accessible by class name. Actually, that is not correct. That is not correct. Why it is not correct? Static members are accessible class name. It is not correct because we are not asking how static members are used. We are asking what is static. What is static? Actually, let's see what is static and where to use them, how to use them. Generally, the word static and non-static are related to memory. The terms static and non-static, they are related to memory. We have static memory and a non-static memory. Generally, what is difference between them is the memory classification. We have two types of memory. So we have two types of memory. Actually, we have a static memory. We have a static memory. And we have a non-static memory. Non-static memory. Or people call as dynamic memory. So memory is categorized into two, static and non-static. Now what is difference is we created a class, some demo. Now in this class, we are having two members, one static S and another non-static N. We have two members, static and non-static. So the static members are stored in static memory. So S is 0. And non-static in non-static memory, N is 0. That means the static members are stored in static memory, non-static are stored in non-static memory. In this memory, we are doing an operation on S, like S equal to S plus 1. We are doing an operation on this static. Okay, we are doing same operation on non-static. N equal to N plus 1. Now what happens is you created an object. This is demo class. This is a class. Okay, you created one object for this class, obj1, that is first object. This object will go and use the static memory, and it will go and use the non-static memory. So a class shares its content into static and non-static memory. Now the object goes to the static memory. In static memory, the S value is finally set to how much? S value is finally set to 1. After it sets to 1, then what this object will do is it will keep the memory alive and it comes out. That means the memory used by object 1 is not destroyed after object 1 finished. That means the memory is still alive. Even when the object finished using it, the memory allocated for object 1 is still alive. But what happens in the case of non-static is, in non-static, n value is finally set to how much? 1. After it finished using non-static, then what will happen is it will reset the memory. It will delete the memory. That means object 1 is using static memory and non-static memory. Non-static memory reset. After object finished using it, it is deleted, destroyed. But static memory is still alive. Now what will happen? You created a complete different object. You created another object, object 2. For the same class, you created object 2. This object 2 will continue using the memory of object 1. That means what memory left by object 1, object 2 will use that memory. It will use that memory. That means in that case, now what is the value of S? 1 plus 1 is equal to how much? 2. Because S is set to 1. If S is set to 1, after S is set to 1, S is increased by 1. Then it will set to how much? 2. That means now what will happen for object 2? The memory left by object 1 is continuing. But when it goes to the static memory, this memory is again newly allocated. That means again the n value is how much? 1. That means what is static memory? If object 3 is created, it will continue the memory of object 2. So what is static memory? Static is continuous memory. And the non-static is discrete memory. Continuous memory means the memory allocated for first object will continue for second. Discrete means memory is newly allocated for every object. Memory is newly allocated for every object. So when to use this? When to use a static memory? When to use a non-static memory? For example, suppose you are doing some money transactions Suppose you take phone pay, Paytm, or some bank app, you are doing some money transaction. You started a transaction of transferring money to a particular person. Then it allocated memory. In that memory, it will allow you to transfer money to that person. After you finish it transferring, while transferring, it will ask what is your password. You confirm the password, it finished a transaction, it transferred the money. After that, to the same person, again, immediately you want to send some more money. Then again, it will ask you password. Why? Just now I entered to the same person I am again sending. Then why you are asking password again? Because the memory allocated for that particular instance is destroyed automatically after the memory completed. Means after the transaction completed. So that is what kind of memory? Discrete memory. That is non-static memory. For example, you are using Gmail. In Gmail, you logged in the first screen and it shows you inbox. It says you have 10 mails. Now you need to watch 10 mails in 10 pages. Then for every mail, it will ask login. That is not good idea. That means for every page, it will ask you to log in. But it should not be like that. When you given login in the first page, it should remember and it should continue for second, third, fourth, fifth page. That means the memory allocated for the first request should continue for the second and third. So now tell me when you will use static memory, when you will use non-static memory. When you are dealing with continuous operations, that means you started an operation and you will continue it, then better go with static memory. If you are using discrete operations, then you go with non-static. That is the reason actually static occupies more memory and static is not safer. Why? Because you finish a transaction and memory is still allocated and second object is not created. Then the memory for first object is still alive. That means the memory is being used and memory leak may happen. It is not safe to keep your memory even when you are not using it. That means it is a burden for application. But if you are looking for continuous operation, then best option is what? Static. If you are looking for discrete operations, then it is non-static. So in TypeScript, it will clearly allow us to allocate static or non-static memory for any member in the class. That means you can say that, okay, this member we will continue. This member we will disconnect. That means a class allowed to configure the static and non-static members. So technically, the point here is static. Actually, it refers to continuous memory. It refers to continuous memory. The memory allocated for first request will continue to the next request, to the next. The memory allocated for first request will continue to the next. It is good for handling continuous operations. It is good for handling continuous operations. So, however, it uses more memory. and may lead to memory leaks. That is, they are concerns only. However, developers will take precautions for handling these, even they are using static memory. They take precautions of preventing memory leaks. They take precautions of destroying the unused memory for a longer time. Such concepts will be used. But these are the direct concerns actually. And static members are defined using static keyword. And important here is you can access static members within or outside class using class name. You can access static members within or outside class using class name. Using class name. So static members within or outside class using class name. Actually, this is the line that many people give as a definition for static, which is not a great definition. Why? Because it is about how you access a static member. It is not about what is a static member, right? So static members are defined in this way. Next, non-static. So it refers to discrete memory. The memory allocated for an object will be destroyed after the uh, it will be destroyed and disposed the object. And it is good for disconnected operations. It is good for disconnected operations, not continuous operations. So it manages the memory. It manages the memory and reduces overhead. You can say overload, not overhead. Another point is non-static members are accessed by using this keyword within class and by using instance of class and outside by using instance of class. They are accessed within the class by using this keyword and outside by using instance of class, by using an object of class. Now let's prove this point. That means we will prove this point how this is possible. What is the concept behind this? So let's see one example to understand this concept. So how you configure and define static and non-static members. So let's see this index.ts. In this, I'm having a class demo. In that, static S is 0, non-static N is 0. And we have a constructor. Here we will define demo.s is equal to demo.s plus 1, because static members are accessed by class name and non-static is accessed by this dot n plus 1. So both are incremented by 1, and we have a print method which is going to print the details. Console.log s is equal to demo.s and n equal to this dot n. Okay. Now what we are doing is we are creating an object one for the demo class. Through that object one, we are printing. Fine. Now we are creating object two for demo class. And through that object two, we are printing print. And we are creating object three for demo class. So three different objects are created. And through object three print. For same class, you are creating three different objects. And all these three objects must use S and N. S is static, N is non-static. See what will happen. Let's compile this now. TSC index.ts and node index.js. Here you can see S is 1, 2, 3, but N is always 1. That means why object 2, it is newly allocating memory. But why it is 2? Because the memory allocated by first object is continued for the second. And the second is continued for the third. So static is a continuous memory. And non-static is a discrete memory. It resets the memory. So this is the concept to understand what is static and non-static. Remember, all three objects are different objects. You see, a new memory is allocated. A new memory is allocated, but still the static memory is continuing. For object one, what memory allocated? It continues. You may ask, like, how much time it will continue like that? Until this module is disposed from memory. Because currently you are using index. Index is a module. In the module, there is a class. And until the module is destroyed, that class memory will continue. It's a static memory will continue. Class static memory is allocated inside the module scope. What is module? The file is module. Index.ts is a module. In that module scope, it is working. That means even the object is destroyed, the still memory is continuing because memory is allocated at module level. And when this module will reset its memory, when you destroy the module, when you switch to another module, then the memory is destroyed. So the static memory of class will continue until the module is completed. Once the module is destroyed, the memory allocated for that class is destroyed. Then even the static memory will reset. When the static memory is going to reset, when you reset the module, automatically the static memory will reset. So that is the concept. That means if I run this again, it will not be 4, 5, 6. It will be again 1, 2, 3 only. Why it is not continuing? Because once you stop it, the module ends. When the module ends, the memory resets for module. Class memory also resets. That means it is not like it is continuing forever, because it is memory at module level which will reset when the module is completed. Even the static memory will reset. When the static memory will reset, when you reset the module. That is the point. So technically, this is one new thing in TypeScript. You can configure static members and you can configure non-static members, which is not possible in JavaScript directly. It is not possible. Okay. Next important, what is new is in JavaScript classes, in TypeScript class members can have access modifiers, can have access modifiers. Access modifiers. We have public and private and protected. A class member can have access modifier. Access modifier define the accessibility restrictions. They define the scope and accessibility restrictions of any particular member. Modifiers are going to define the scope and restriction for a member. This is not possible in general JavaScript. So here what is new in the class of TypeScript is static, non-static members. Another one is access modifiers. What is meant by public? So it can be accessed from any location. So it can be accessed. It can be accessed from any location. It can be accessed by using any instance. Any instance. So the base class or derived class. It can be accessed from any location. Any location means, so it can be within class or outside class. So that is public. Actually, it is default access modifier. Generally, in several programming languages, private is default. Some programming languages have private, some programming languages have internal like that. Some access modifiers are there. That means by default, some are private in access. They are not public in access. That means, so they are accessible. What is the meaning of private? So it is accessible only inside class. Inside class. That is within class. It is accessible only inside class. It is not accessible from anywhere. So that is private. What is protected? So it is accessible within the class. Within the class. And it is accessible outside class, but only inside derived class by using derived class object. Or derived class reference. Derived class object or derived class reference. It is accessible outside class, but only inside derived class and by using derived class object or derived class reference. that is more restricted actually. So that is protected. So now how it is possible? That means what is the difference here is, for example, see, so this is the class and the class is a product. And in this product class, we are having some members. So public name is a string type. Okay. We have a private price as number type. So, and we are having like protected some stock. It is a Boolean type, true, false, something like this. Now we have a class as derived. This derived class extends which one? Product. Now here we have a print method. So public, so print method, it is a void type functions how we configure. Here also we are having a public print method. So a void type, we are configuring like this. Now the point is we are creating outside an object for derived. Now through this object, which members you can access? Only public. Only public. Protected is not accessible. Private is never accessible. Protected is not accessible. Why? Because see the definition. What is protected means it is accessible outside class, but not anywhere. Only in derived class. In derived class, not by using derived class object anywhere. Derived class object inside derived class. For example, through OBJ, you can access only name and print because they are public. We can access only name and print. Name is accessible and print is accessible because these two are which members? Public members. These two are public members, you can access them. Now, inside the derived class, you create an object for product. Now, which one is accessible? Here again, public only. Again, public only accessible. Why? Because object belongs to whom? Derived class or super class? Object belongs to whom? Object belongs to super class. Na? It is not derived class object. If it is super class, it can access only public. How protected is accessible then? That means you see OBJ, it access only name and print. How you can access the protected is by creating an object of which class? Derived class. Inside the derived class, then through that you can access the protected member. You can access name and you can access print and you can access what? Stock. So what is about protected member? Protected member is accessible inside derived class using derived class reference. It is not accessible anywhere else. Outside the class it is accessible, but it should be inside derived class. And that also by using derived class object. That means it have more restrictions. Actually, you can do like this. You can configure this OBJ. You can configure this OBJ. OBJ is the reference. What type reference it is, what derived. Through that OBJ, it can access. But actually print is not possible because it is having same name arguments. That means it is not possible for that. We can give a different name. But the point is how you can access the protected member. Protected member is accessible by using derived class, within the derived class by using an derived class object. That is the concept of protected. So these two are public here. This is public and this is public and this is protected. Protected is accessible. Now all are accessible within the class. That means public is accessible, this dot name, this dot price, private is accessible, this dot stock, all are accessible within the class. This is just a syntax to show you how they are accessible. Within the class, all are accessible. Outside the class, public is accessible everywhere, but protected is accessible outside the class only inside derived class by using derived class object. That is the restriction. These three access modifiers are there for the members in a class. You can configure them: public, private, and protected. This is something new other than the concepts of properties, methods, and constructors. This is new thing. So class have some new concept and some more concepts are new. You can have abstractions, you can have generics. These are enums. These are the new things that you will learn while working with the OOPS that we'll see next session. Right? Monday mostly it will take 2 more days to finish the new things of OOP in TypeScript. Then we can start building a project, another project with React and TypeScript. That means we will build another complete project by using React and TypeScript. So you will have 2 projects idea, one with JavaScript, another one with TypeScript, right? That we will continue. Then to Monday we will see that. Okay, right. Thank you.